Okay, so before we go too far down this path, I did want to say that I was contacted by the folks at AURSINC, and they asked if I would do a video review of the LibreVNA. And of course I said yes, so they sent this to me free of charge in exchange for this video review. Let's go ahead and see what's inside. First, you have a user manual, and in taking a look at this, I'm going to need my explaining glasses in order to read it. But I did take a look at this, and it seems to be well written and reasonably complete. Here is the LibreVNA itself. You can see there are a number of screws here that hold this thing together. And this is much smaller than I expected it to be. Here we have a bunch of status or display lights. You have an out and an in reference if you wanted to use an outboard clock or something along those lines. You have a USB-C port right here that allows you to charge, or allows you to power this device and connect it to a computer. It also has a DC 5 volt 1.5 amp input port here for power. And then here it has your port 1 and your port 2. Again, I'm really surprised at the size of this thing and how small it is. It's my understanding that this device uses itself as a heat sink and can get rather warm. So if you're going to use something like this, I would imagine that you'd want to set that on something to stop or help with heat dissipation. So here we have a couple of coax jumpers with SMA male connectors on there. No surprise there, you typically see that sort of thing with the VNA. And then here we have a USB-C cable. Let's take a quick peek at this. Again, this is for powering the device or connecting it to the, oh, look at this. This is USB to the 1.5 amp jack on the back. So you probably need to supply your own cable to connect this to a PC. Here are some rubber feet, and then here are some test standards. It comes with two SMA male to SMA male through connectors. Here is a 50 ohm load and another 50 ohm load, as well as two SMA female to female through connectors. This looks to be a short load, and then this would be your open. All right, well, let's get this thing connected, powered up, and see what it does. Okay, so I wanted to quickly show where you can pick some of these things up. Here is an Amazon link that I will include below. And as you can see from the price here, $545.99, that these things aren't cheap, but part of the reasoning behind the price is the capability that you get up to 6 gigahertz of measurement, as well as full 2-port measurements, S11, S12, S21, and S22. Now, I'll have a video linked below that explains S measurements. You can take a look at that and maybe get a better understanding if it's necessary. Here you can see that it is a full network analyzer, vector network analyzer, and it talks all about all those measurements I just mentioned. And then it says for simple measurements, if no dedicated spectrum analyzer is available, you would be able to use this as a limited spectrum analyzer. And it also has a signal generator function. So that's pretty neat, pretty interesting. And what I wanted to cover down here are some more of the specifications. You can see it's a 50 ohm impedance unit with 2 test ports. Talks a little bit about range, accuracy, a number of measurement points up to 4,501. That's fantastic. Talks about port speed, bandwidth measurements, dynamic range. Down here, there's a note around dynamic range is higher than 3 gigahertz. This likely uses harmonics to go above 3 gigahertz. I don't know for sure, so don't take me as gospel on that, but that may have something to do with some of the reduced dynamic range. The other thing I wanted to mention here is power supply. We talk a little bit about that. DC 5 volts, 1.5 amps, USB powered, or 3.5 millimeter connector. And power consumption approximately 7 watts. USB Type-C interface, which is fantastic, and then supported operating systems, Windows, Linux, and Mac OS. Only 64-bit software is available now, but that's okay. We run 64-bit software. And then it talks a little bit about your external input and output references. So, like I said, I'll have a link to this below, and you'll be able to come here and check out some more information if necessary. I'll include all of these links below. So here is a copy of the LibreVNA user manual. When you come down here, contents overview, USB and external power, let's take a look there and see what this recommends. So here's the external power based off that USB cable that we took a look at in the unboxing. And it says external power is optional. And then here's USB. I'm assuming that you can power via either one of these ports. The LibreVNA uses a USB-C connector as the power supply and for data transmission. The hardware supports the USB power supply delivery standard, requires 5 volts and draws up to 1.2 amps of current. 1.2 for external power says input jack for DC power, 5 volts, 1.5 amps, positive center pin. If a power source is connected, no current is drawn from the USB port anymore. So there you have a couple of different options for powering the device. So here is the main GitHub page, and you can see that there's a variety of different things here that you can take a look at. Let's take a quick look at the README. This is the improved version of my first attempt at VNA, and here is the board. We want to install the software. So what it says here for GUI installation or graphical user interface installation, download the latest release, unpack the zip file, start the included LibreVNA GUI exe. No installation or drivers required. Simply move the extracted folder somewhere convenient. So let's go ahead and we will download that. Embedded firmware, LibreVNA GUI OS X, Ubuntu, Windows source code. And this is the latest version 1.21, and you can see it. So I have this file, GUI for Windows, inside my downloads folder in a subfolder called LibreVNA. So I'm just going to go ahead and I'm going to right click on this, and then I'm going to pick extract all. Here it asks me where I want to extract the file to. This location is fine for me, so I'm going to click extract. Inside the extracted archive, there's a folder called release. I'm going to double click on that, and I have all kinds of stuff. And there is a LibreVNA GUI.exe, and this will likely run the interface. So this is telling me this is from an unknown publisher. A lot of people say, well, this means it has a virus. What it means is that this does not have a certificate of authenticity from the provider or publisher. I'm going to go ahead and run anyway because I live life in the danger zone. And then here's the LibreVNA GUI 1.2.1. What I want to do now is I want to connect my LibreVNA to my computer. So taking a look at the manual, I can scroll down and I can see Chapter 3, Vector Network Analyzer. It has a section 3.5 for calibration, and it goes over all of these different things. Let's go ahead and take a look at Section 3. Here we go. In this operating mode, the LibreVNA takes S parameter measurements. I'll have a link to a video below that kind of explains S parameter measurements, and you can check that out. A source signal is generated and alternately applied to RF ports. The incoming signal of both RF ports is measured, resulting in 4 parameters, S11, S21, when the source signal is routed to port 1, as well as S12 and S22 when routed to port 2. The Nano VNA is only capable of doing S11 and S21 measurements. The ability to do 1.2 and 2.2 measurements are why this VNA is so intriguing to me. It talks a little bit about the processing architecture, a sweep toolbar, traces, and let's go down and see around calibration. So this section is about the calibration. It talks about the calibration kit that we took a look at in the unboxing video. It talks about measurements and calibration types. So there are different types of calibrations available, and this is actually a pretty good explanation of them. So you can apply a port 1 or port 2 calibration, a SOLT calibration, which is short, open, load, and through test. And this is a full 2-port calibration, removing influences at both ports and also corrects transmission measurement. We are going to be doing a SOLT calibration in this video. You can normalize a calibration in the event that something has changed and you want to adjust for that. And then it has a TRL. I'm familiar with TRD, which is time reflection domain. This TRL, I'm not 100% sure what that is. It looks over here that there is a required measurement called line. We can investigate that as well. It talks about your calibration kit and how you can edit the measurements here. You can save your measurements in a touchstone file, which is pretty handy. And then here is actually how you perform the measurements. Let's go ahead. Also, you can enable your calibration once done. Let's go ahead and actually calibrate this device. Okay, we've connected the LibreVNA to my computer using the USB-C port. And from the GUI application, what I want to do is I want to click Device, and I want to click Update Device List. So I've done that, and I see no information available yet down in the lower left-hand corner. Let's take a look in Device Manager. When I take a look in Device Manager, I'm looking under ports, COM, and LPT, and I see Communications Port 1. That's what I expect to see. Let me go ahead. I'm going to disconnect the LibreVNA, and then I am going to reconnect it to see if anything happens. Now that it's disconnected, you can still see COM1. Reconnecting it, I still see COM1. So I'm not sure that my computer is actually seeing the device. Okay, this may have been an error on my part. When I click on device, now I have connect to bolded, and then I can pick this device here. And there we go. I'm also seeing some activity lights on the Nano VNA. Down here in the device log, you can see that we have some information going back and forth, and we're actively taking some readings. In the lower left-hand corner here, you can see connected to the device. Taking a quick look through my eye in the sky cam, you can see the device is connected, and we do have activity across these lights. So we get a warning. It says this device reports a different protocol version 8 than expected 7. A firmware update is strongly recommended. Do you want to update now? Why not? So let's go ahead and click yes and see what happens. And there we go. We don't have a firmware update available. Let me see if I can find one. We did download embedded firmware hardware revision B. Let's go ahead and extract that. In that folder, we do have a VNA FW combined and a VA embedded ELF. In the user manual, there's a section 224. It has some language and a diagram here that says firmware update. Load a new microcontroller firmware and FPGA configuration into the LibreVNA. Do not disconnect power while updating the firmware. And here it is a VNA FW file. So in our downloads, we did have this folder embedded firmware, and we have a VNA firmware update file. So let's go ahead and open that. Now I'm going to click this start button, and that should start applying my firmware. You can see in the device log window, there's a lot of activity. It's rebooting the device. And we are back up and in business, and it is still connected. There was nothing that I needed to do there. Okay, so now we have the software up and running, and what I want to do here is I want to calibrate the LibreVNA. And this is a new device to me, and I haven't had much experience with it other than taking it out of the box today and connecting it up. We did the firmware update. So I'm actually just going to calibrate it as is. If you take a look at the top of the toolbar, you'll see that our sweep type is set for frequency. You can also do power. We are starting at 1 megahertz. Center is 3 gigahertz. There's a little bit of spare change left over. And the stop is at 6 gigahertz. And our span is 5.999 gigahertz. I don't think that I would typically calibrate a VNA at that large of a sweep setting, just based off of what I typically do with a VNA. I think I would adjust this and then create particular use case calibrations. Here you can adjust your data points. It's set for 501. We're going to just go ahead and we're going to leave it there. If I come over to this window and I go to calibration, there is a setting here called calibration measurements. And when I click on that, I believe this is how and where I would apply these calibration measurements. So the first one is port 1 short. Open standard connected to port 1. Port 2 is open. So what I think I'm going to do here is I'm going to connect my short standard to port 1. And I'm going to go ahead and I'm going to do this on my overhead camera so you can play along. Okay, so here's the LibreVNA. Please excuse some of the mess. We're going to take our port 1, and then we are going to take our short standard, which is right here. And I'm going to go ahead and I'm going to attach that. When I do this, I want to make sure that it's snug, but it's not over tight. Let's go ahead and switch back to the desktop. Okay, so here we are in the desktop view. I'm going to highlight this one, port 1 short, and then I'm going to click measure. And there you can see it has been applied. Let's go to port 1 open. And again, I'm just going to take the open standard and connect that to port 1. Okay, that's been connected, and I'm going to hit measure. And now that's complete. Taking a look at the statistics window, you can see it says 500 points from 1 megahertz to 6 gigahertz. Now what we want to do is we want to connect the load standard to port 1. Okay, I'm going to click measure. And now we have that. The next thing I want to do is I want to move over to port 2. So it says port 2 short. What I'm going to do is I want to leave port 1 open, and I'm going to connect the short to port 2. Okay, next we are going to do port 2 open. I don't know how well this is going to come across, but you can see that there is some engraving on your standards if there's any confusion as to which one is which. Okay, we are going to run a measure. Next is port 2 load. So let's go ahead and click a load. Connect a load. Click measure. Okay, what we are going to do is a through measurement. So this is port 1 connected to port 2 via a through standard. Let's go ahead and do that. So what I'm going to do is I'm going to take one of these SMA female to female connectors, and then I'm going to connect this coaxial cable and then I'm going to connect this coaxial cable. And while this cable is flexible, it's not super flexible. Let's go ahead and measure. Now we want to do an isolation, and it says both ports terminated in the 50 ohm. So the LibreVNA comes with two 50 ohm loads. Let's go ahead and connect those. Go ahead and click measure. And then line for the line type calibration. Port 1 connected to port 2 via line standard. Not available. So that means we haven't done it yet. So let's go ahead and do that. Now, one thing I'm going to say is that I've never done a line calibration measurement on any of the VNAs that I have. I've done all of the other ones. So let's go ahead and connect a line up, which is going to be different than the through. I believe the through uses two cables, and then the line uses a single cable. And I'm willing to receive feedback from any of the experts in the comments section. So if I did this incorrectly or you have additional information, please go ahead and leave that below. Let's go back to the desktop. And then we want to go ahead and we want to hit measure. Okay, so we've taken all the measurements that we need for our calibration. Let's go back to the software and do some actual measurements. All right, so when we take a look at this interface, I've got 4 different charts here, which is cool. I've got one for S11, S12, S21, and S22. Maybe I don't want to look at all of that at the same time. So what I'm trying to figure out is how I can just get one chart on my screen. And I guess I can go close tile and do that. And then I can do close, close tile, close, and close tile. Yeah, that's pretty cool. And then I can go from here and I guess I can go to setup. No, that's not it. Close. And then I can do, there we go. There we go. So I can look at a magnitude across frequency, and that is awesome. So let me go ahead and I want to hit OK, and then I want to come over here and I pick whichever measurement. So when I take a look at an S11 measurement, what I'm taking a look at is a magnitude in decibels of a signal that is going out port 1 and being reflected back into port 1, which is pretty handy. Let's see if we can add a marker on here. Oh, look at this, add a marker. So there I've got a marker, and I can see over on the right-hand side a frequency and then a reading. Well, that's pretty cool. And I can also take a look at this. Let's go to close, and we can look at the values on a Smith chart. There we go. All right, this is pretty cool stuff. Let's actually set something up on this Nano VNA and actually measure a real device. Okay, so we're just going to take a poke around the user interface. It's been a day or two since I played with this. I saved a calibration and was able to load it, and that was pretty easy stuff. We're taking a look at a FM bandpass filter or an FM stop filter. Let's go ahead and take a look through the overhead cam so you can see what this looks like. Okay, so here's the LibreVNA, and I do have it set on something because it does get warm, as we discussed before. Here's a USB cord that connects to my computer. And then here is a filter that I use in my videos often. It's from 88 to 108 megahertz, and what it does is it attenuates signals at those ratios or at those frequencies to block any FM band interference that you may be getting on a radio or some kind of interface. Here we have this in just a through configuration. So let's go back to the application. So we have a couple of different charts and graphs here. I want to clean 2 of these up. So what I can do is I can actually come here and go close and then close tile, and then I get a larger on my screen S21 measurement. I'm going to do the same thing with this one. I'm going to go ahead and I'm going to close that one. And this is an S21. So this is coming out of the second port into the first, and it's measuring attenuation. And this is on the full span. So for the calibration that I did it from 1 megahertz to 3 gigahertz, which is way more than I would typically use for most of the tasks that I use a VNA for. But I just wanted to see it, and you can see the shape of the blocked frequencies down to about 60 dBs. And this readings that we're getting here are consistent with other tools that I've used this filter on. And what I see here is a zoomed in view of the attenuation, and it's similar, but what I like about this is that I can look at it bidirectionally through the different ports, and then I can look at two different charts here and I can compare to see how well something works at its given task, whether it's a band stop or a band pass filter or low pass or high pass filter or any other device like you would use in ham radio, like a trap or something like that. So this is actually pretty cool. What I want to do next, I can go into these tools and I can pick different measurements that we want to do. So I think what I want to do next is I want to connect my end-fed half-wave dipole antenna that I use for amateur radio and get a little bit of a reading there. So let me go ahead and do that now. Okay, so we have the end-fed half-wave set up, and this is about what I expected to see in terms of a sweep. I don't think this is 100% exact, because if you remember, our calibration is only 501 data points and it went to 3 gigahertz. If I was serious about measuring this antenna, I would calibrate a specific calibration set for this use case or test. But here you can see it's about 6.2 megahertz all the way up to 7.4. What is that? 7.475, which is the 40 meter band is down below 2. Actually, I want to go in a setup real quick, and I'm going to set my division to 0.5 and see if that helps out. And so you can see parts of this are below 1.5, which is where you'd want your SWR. So I'm not too worried about the state of my antenna, but again, I'm not 100% convinced that this is accurate based off our calibration. The end-fed half-wave dipole is near resonant on 40. This would be 20 meters, and you can see we're at about below 1.5, 3.8 to 4.34, which is just about all the 20 meter band. This is 15, and we have some good looking SWR there, as well as a 10 megahertz. So I'm pretty happy with this. As I mentioned, there's also signal generator and spectrum analyzer functions that I have not tested or messed with at all. So I'm not 100% sure how to do that, but I'm really impressed. I really like the LibreVNA. I'm very happy that AURSINC sent it to me for evaluation. And I think this will be a long-term piece of equipment or instrument that we'll be using in our videos moving forward. So if you have any questions, comments, suggestions, or recommendations, go ahead and post them below and I'll do my best to respond. Thank you very much.